Hey everyone, this is a video to take a look at how to compute integrals with Desmos, and these are bounded integrals, so for the most part anyway. So we're going to go ahead and just type in int, and that will bring up the integral symbol, and then you can go ahead and put in your bounds. So I'm going to use a similar function that I did in another video. So let's say we do 0, and if you just use the up arrow, or you can click there if you like, we'll put 3. Again, you can use a right arrow or just click outside that bound, and then you can start typing. So you can do x plus sine x and then dx. And what you'll see here is kind of this warning. Integram must end with an integration variable like dx. We see that it does, but a lot of times what you'll have to do is put in some parentheses around your function, so something like that, and then it will know this is where my function ends, there's my dx, and then it'll compute it out. So a lot of times that's just something that you'll have to do, is put parentheses around whatever you want to integrate, and then you can put it in dx. So if you want to go ahead and define a function, so I'm going to say y1 is x plus sine x. So there's our function. We're going 0 to 3, finding the area right under there. Now, similar to the TI 83 or 84, you can go ahead and also use y1 instead of just typing in the whole function if you already have it somewhere else. So if you've already defined, say, this y1 is x plus sine x, I can just type it in that way with the dx and it'll compute it out. So sometimes this can be a time saver if you're combining multiple functions, just to write them out with these definitions, y1, y2, y3, and then do it that way. A couple nice things about Desmos is that it will also do integrals with respect to other variables. So if you want the integral from 0 to 3, let's say sine of y plus y, and I'm going to put in some variable or some parentheses here, and then dy. It'll integrate those with respect to y, so you don't have to worry about your integrals in terms of y or t or some other variable. You can just type it in like that. You don't have to change it back to x or anything like you do on the calculator. So sometimes that's kind of nice, depending on what you're looking at. You may just want to leave it in terms of y, and that's fine in Desmos. Another thing you could do is, let's say up here I want to graph x1 is y plus sine y. Now Desmos will do these x in terms of y types of graphs. So if I want to integrate, say, integral from 0 to 3 x1 dy, then that will also do the same thing as before. So that'll take this x1, use that definition in terms of y, and then integrate with respect to y using that dy. So a couple things you can do there, just either typing it all in or doing that kind of definition replacement. One last thing I wanted to show you, and I'm going to close a couple of these out. Let's say I want to integrate from 0 to x. So we saw this in the fundamental theorem of calculus. This is going to be an antiderivative of whatever I put in. So I'm just going to put in something nice like 2x. And even something simple like that. A lot of times I forget the parentheses, but you kind of need them in there. And it says it doesn't know what to compute on that, so it's not going to compute anything out. But what you can do is go ahead and call this a function of x, and then typically it will graph this. So let me just figure out what's wrong here. Alright, so kind of classic mistake. And it tells you in the warning, integration bounds can't depend on the integration variable. So typical mistake there. These should be in terms of some other variable like t or a or whatever you like. But the integral from 0 to x of this 2t dt, and I'm going to go ahead and hide this other one. So we expect that to be an antiderivative of 2t, which would be just t squared, but in terms of x. So there's my x squared function that's right there. If you change this lower bound, say to 1, it'll be a similar curve, just shifted up or down. This is another antiderivative, but with that plus c constant being a little different. So now if I have this 1 as my upper bound, I'm integrating 1 to 1, and that should be a 0 value right there. So it'll just adjust the height depending on what value you have as this lower bound. So that's kind of a nice way to be able to visualize these sort of antiderivatives. Let's put in one we don't really know. So x, sine of x squared, let's say. So that's kind of a nice, crazy antiderivative, but the sine of x squared doesn't have a nice elementary thing like we can do with 2x and just get x squared out. So this will actually give us a graph that we can look at to visualize this antiderivative of the sine of x squared. So that's another nice thing in Desmos. Again, you're not really going to be able to do that with the TI calculator. Just like you can't really graph x in terms of y very easily on there as well. But for those types of applications, Desmos is pretty nice. You can just type it right in, it'll do it. So anyway, that will do it for looking at integrals with Desmos.